Okay. Good afternoon, class. I hope you're enjoying this wonderful day. Really nice weather. I went for a run in the sun. It was nice. And so I hope you had a chance to go outside and enjoy it, even if it was only in your backyard. Hello, Will. So today is our last day on the Sudoku method. And this is going to be the most complicated Sudoku method problem. So this is kind of like the maximum level of difficulty. Hello, Izzy. Hello, who is Lego Crafter? Hello, I think I've asked that before, but who is Lego Crafter? I forgot. So let me just name these quantities so that you guys, oh, Matthew. Matthew, I got your email and I'll correct that. Hi, Goldie. Hey, Sebastian. So this is a 24-volt battery, 2 ohm resistor, 3 ohm resistor, 4 ohm resistor, 5 ohm resistor, 6 ohm resistor, 7 ohm resistor. Okay. So I'm going to make my table for the Sudoku method. Volts V, current I, and resistance R. Hopefully I can finish this problem on one page. So first row, I like to put the battery, 24 volts, undefined resistance. Then I have all the resistors, 2, 3, 4, 5, 6, 7. So let's kind of block out what's going on in this circuit, okay? See how the 6 and the 7 are in parallel. That means that they're going to have the same voltage. So I'll put stars there to remind myself of that. Okay. The 2, the 3, and the 4 are also in parallel. So all of those will have the same voltage. Okay. Bug is barking at all the passersby today. And then lastly, this is, hey Ray. Lastly, this one is kind of probably non-intuitive, but actually the 5 ohm resistor is in series with the battery. Why is that? Well, any current that comes out of the battery, okay, is going to be split into 3 ways. But then that current is going to come back together and it's going to go right through the 5 ohm resistor. So whatever current comes out of the battery is eventually going to make its way through the 5 ohm resistor. So the battery and the 5 ohm resistor have the same current. Okay? So I like to think about this circuit as it's essentially a voltage divider, right? You can see there's 3 blocks, this block, and this block. And each block in the voltage divider is a current divider, okay? So it's a voltage divider made up out of current dividers. That's how I see this circuit. So first step, as always, is to figure out what is the battery current, okay? And so again, I see it's this block in series with that block in series with that block. Whoop.
Just a sec.
Wow, that was a little bit creepy. I was saying the word series and my phone registered it as Siri. And then I said, so, all right. So what is the total resistance of the circuit? Hey, Charlotte. So it's going to be 2 ohms in parallel with 3 ohms in parallel with 4 ohms. So those 3 in parallel. In series with the 5 ohm. In series with the 6 and the 7 in parallel. Okay, so I'm going to write it like that. I won't bore you with the mathematical calculation. So let me just do this really quickly. So the total resistance of this circuit is 9.2 ohms. All right, and so then I can get battery current with Ohm's law. V equals IR. So I have 24 equals I times 9.2. Um, 2.6 amps is the current. So this is 2.6 amps, which means that this is also 2.6 amps, which I can then multiply this out to get the voltage drop, which is going to be, looks like that will be 13 volts. Okay. So now I'm kind of stuck. So what I'm going to do is I know that 2.6 amps goes through this 5 ohm resistor. Okay. And so I'm going to analyze this current divider right here. So I know that from Kirchhoff's current law, I know that the current that goes through the 6 ohm resistor plus the current that goes through the 7 ohm resistor has to equal 2.6. Okay. Furthermore, I know that the voltage drop across the 6 ohm resistor is equal to the voltage drop across the 7 ohm resistor because of SIPOV. So what that means is that I6 solve for I6 and I7. So this says that I6 equals 1.2 I7, which I can then plug into here. So I have 1.2 I7 plus I7 equals 2.6. That says that I7 equals about 1.2 amps. I'm doing some rounding here. The remainder of that current is going to go to I6, which would be 1.4 amps. Okay. So I can fill in these right here. So I have I7 is 1.2, I6 is 1.4. Then I can multiply across to get the voltages. So this is 8.4 and 8.4. So I got the same voltage. Okay. So now I'm kind of stuck again. And so, hey, Jaden. So what I'm going to do now is I'm going to do a Kirchhoff's voltage law loop. around here. So you know what? I'm going to draw the loop in. Like that. So I'm going to do that loop. So remember, Kirchhoff's voltage law says the voltage changes around a loop have to be equal to 0. So I have a 24 volt rise. Then I have a drop across the 2 ohm resistor that is unknown. So I have minus V, where V is unknown. Then I have the drop across the 5 ohm resistor. The 5 ohm resistor has a drop of 13 volts. Then I have a drop across the 6 ohm resistor, which I know the 6 ohm resistor has a drop of 8.4. And then that completes my loop. So I can solve for the voltage drop across the 2 ohm resistor. 24 minus 13 minus 8.4 equals 2.6 volts. So that means that this is 2.6, which means that all of them are 2.6 because they're all in parallel. And then it is rather trivial to figure out that this is 1.3 using Ohm's law. This is 0.9. And this is 0.7. If I add these three currents up, I get 2.2, 2.9. I get 2.9 if I add these up. These three currents should equal 2.6 because that's the battery current. Why is it not equal? It's because I did a lot of rounding in this problem, and anytime you do rounding, it causes little inaccuracies. But this is approximately correct. All right, so you should all be masters of the Sudoku method after today's daily item. Tomorrow and Friday, we're just going to do some random circuit topics to finish out circuits. And then once we come back from spring break, we're going to do some ends. And then we'll start reviewing for the AP exam, I guess. And then hopefully we'll be back in class together. All right. Enjoy the rest of your afternoon. Go sit in your backyard and relax if you get the chance because it's a really nice day. Bye now.